Welcome to Trinath chemistry classes. In this video, I am going to discuss about intermediate first year chemistry topic, hydrocarbons. In this hydrocarbons topic, I am going to discuss about various physical and chemical properties of alkynes. In my previous video, I have already discussed how alkynes are prepared. In this video, mainly focusing on some of the chemical properties of alkynes. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel. So first one is physical properties. Physical properties. So in this alkynes, the first three members, that is C2 to C5 are gases. The first three members are like alkenes and alkanes. The first three members are gases, and the next 8 members, that is from C6 to C13 or C14, are liquids. Next 8 members of liquids, and from C14 onwards solids. C14 onwards solids. So in this alkyne series, the first 3 members are gases, the next 8 members are liquids, and the higher ones, the more than C14 are all are solids. And all alkynes are colorless. All alkynes are colorless. And ethane, that is C2H2, has a characteristic water. But other members, that is beyond the C2H2, all others are colorless and waterless. Whereas ethane is colorless, but it has its own characteristic water. It has its own characteristic water. And these alkynes, they are weakly polar in nature. Weakly polar in nature, and they are lighter than water. They are lighter than water. And immiscible in water. But soluble in organic solvents like benzene. So the first three members are the gases, the next 8 members are the liquids, and beyond that are solids. All alkynes are colorless, but all alkynes except acetylene waterless. Acetylene is colorless and it has its own characteristic odor. So these are weakly polar in nature, but lighter than water, and immiscible in water, but soluble in organic solvents such as ether or carbon tetrachloride, benzene. Like this, they are soluble. So these are the various physical properties of the alkynes. Now let me discuss the chemical properties. Chemical properties of the alkynes. Chemical properties of the alkyne. Chemical properties. So we have already seen in carbon in alkynes, the carbon contains 5 bonds, but this is one sigma bond and 2 pi bond. So as like alkenes, alkynes also contain loosely held pi electrons. Alkynes also will participate in electrophilic addition reactions. Electrophilic addition reactions. Electrophilic addition reactions. Alkynes also will participate in electrophilic addition reactions due to presence of loosely held pi electrons. Loosely held pi electrons. So in this, the first one is a reaction with sodium and sodium. Sodium and sodium. So when alkynes containing terminal hydrogens are treated with sodium, they form sodium acetylide, sodium acetylide, sodium acetylide. Right? Similarly, when treated with sodomite, NaNH2 is called sodomite, and here also it forms. These reactions shows that the compounds which on reaction with metals, right? Which on reaction with metals liberates hydrogen gas. Those are nothing but behaves like acids. Behaves like they show acidic character. So the terminal alkynes, you see, terminal means if it contains C double bonds, if it contains at least one H group, terminal, these are called terminal. For example, if you take 2-butane, it is non-terminal. So in terminal alkynes, these terminal alkynes reacts with sodium and sodamide and liberates hydrogen gas. This reaction shows that the proton, the hydrogen present in the alkynes is acidic in nature. So these two reactions are not shown by either alkenes and alkanes. So this reactions shows that the proton, the hydrogen present in the alkynes is acidic. So this is the first one, reaction with the sodium and sodamide. So alkynes on reaction with sodium or sodamide and sodium metal and sodamide. So these are behaving as strong bases. Sodium and sodamide are behaving as strong bases. So that's why they are reacting with ethane and forming sodium acetylide. This is the compound nothing but sodium acetylide and liberates hydrogen gas. So this reaction shows that the proton present in the alkynes is acidic in nature. So this is the first. Second one is reaction with hydrogen. Reaction with dihydrogen. When alkynes on reaction with H2 in the presence of catalysts such as platinum, palladium, nickel, initially forms alkenes which undergo further hydrogenation and forms alkanes. So when alkynes on reaction with hydrogen in the presence of on reaction with hydrogen in the presence of catalysts such as platinum, palladium, or nickel, initially forms alkenes, and which undergo further hydrogenation and forms alkanes. For example, if you take ethane adds to the one molecule of H2 in the presence of nickel, platinum, or palladium, initially forms ethene. So which further undergoes hydrogenation, and forms ethane. Similarly, let me take one more example. If you take propine, so propine on reaction adds to the two molecules of hydrogen in the presence of platinum, palladium, or nickel, forms CH3, CH2, CH. So this is nothing but propane. But initially forms propene. And later on further reaction gives propane. So in place of two pi bonds, two hydrogen molecules are adding. So this is an example of the electrophilic addition reactions of alkynes. So reaction with dihydrogen, when alkynes on reaction with hydrogen in the presence of catalysts such as platinum, palladium, nickel, initially forms alkenes, which undergoes further hydrogenation and forms alkanes. So ivi initial ga manaki alkenes ni form chestunnai, మళ్ళీ ఫర్దర్ గా రిడక్షన్ జరిగి మనకి ఏమవుతుందంటే కనుకండి ఆల్కైన్స్ ఫామ్ అవుతుంది. సో ఇవే ఆల్కైన్స్ తీసుకుంటే కనుకండి సేమ్ దిస్ హైడ్రోజనేషన్ రిడక్షన్ మనం కనుక అబ్జర్వ్ చేస్తే కనుక ఇన్ ది ప్రజెన్స్ ఆఫ్ ప్లాటినం ఆర్ పలాడియం ఏమొస్తుందని చెప్పినాం, ప్లాటినం ఆర్ పలాడియం లేదా నికెల్ ఇలాంటి catalyst presence లో అయితే కనుక ఫైనల్ ప్రొడక్ట్ ఎవరు వస్తారని చెప్తున్నాం, ఈథేన్ ఆల్కేన్స్ వస్తున్నాయి. అలా కాకుండా కనుక ఇవే దాన్ని హైడ్రోజనేషన్ ఇన్ ది ప్రజెన్స్ ఆఫ్ లెండ్లార్స్ catalyst, సో దీన్ని H2 by palladium by barium sulfate, దీన్ని ఏమన్నా లెండ్లార్స్ catalyst ప్రజెన్స్ లో చేస్తే కనుక ఏం జరుగుతుందని చెప్తున్నాం, ఆల్కీన్స్ వస్తాయి. అదే హైడ్రోజనేషన్ ఇన్ సోడియం బై లిక్విడ్ అమోనియా చేసినా కూడా మనకి ఇక్కడ ఎక్కడ అయిపోతుందని చెప్తున్నాం, ఆల్కీన్స్. సో ద బేసిక్ డిఫరెన్స్ బిట్వీన్ దీస్ టూ రియాక్షన్స్, ఇక్కడ కంప్లీట్ హైడ్రోజనేషన్ జరుగుతుంది, ఇక్కడ ఏం జరుగుతుంది, పార్షియల్ హైడ్రోజనేషన్ జరుగుతుంది. ఏం జరుగుతుందండి, ఇక్కడ పార్షియల్ హైడ్రోజనేషన్ జరుగుతుంది. సో మనకి ఈ లెండ్లార్స్ catalyst ప్రజెన్స్ లో వచ్చేటటువంటివి సిస్ ఆల్కిన్స్ అయితే కనుక, అదే దీంట్లో వచ్చేవైతే కనుక ఏ ఆల్కిన్స్ అంటే ట్రాన్స్ ఆల్కిన్స్ వస్తుంటాయి, రైట్. సో హైడ్రోజనేషన్ ఇన్ ది ప్రజెన్స్ ఆఫ్ నికెల్ catalyst ఆర్ ప్లాటినం ఆర్ పలాడియం, మనకు ఫైనల్ ఇనిషియల్ గా ఆల్కిన్స్ ఫామ్ అవుతున్నాయి, బట్ ఫైనల్ గా ఎవరు వస్తున్నారని చెప్తున్నాం, ఆల్కేన్స్ అని. బట్ పార్షియల్ హైడ్రోజనేషన్ జరిగి ఆల్కీన్స్ దగ్గర ఆగిపోవాలంటే we have to use either లెండ్లార్స్ catalyst or sodium by liquidum. So this is the third reaction, hydrogenation or reduction or reaction with hydrogen in the presence of Lendlar's catalyst and sodium by liquid amount. Next, third one is reaction with halogens. Reaction with halogens. Reaction with halogens, right? When alkynes on reaction with halogens, initially forms alkynyl halides and further reaction forms dihalides. Dihalides. So, for example, if you take acetylene, CH, if we are adding bromine, so initially it adds to the one molecule. Tetrahalides forms tetrahalides. Here, dihalides are formed, initially forms dihalides. So which undergoes further reaction and forms right. So when alkynes on reaction with halogens initially forms dihalides, initially forms dihalides, and on further reaction forms tetrahalides. On further reaction forms tetrahalides. Right? When alkynes on reaction with halogens initially forms dihalides. That is, vicinal dihalides are formed, which on further reaction forms tetrahalides. So this is the third one, reaction with halogens. And next one is reaction with hydrogen halides. Reaction with hydrogen halides. Reaction with hydrogen. When alkynes on reaction with HX, hydrogen halides forms alkynyl halides, which on further reaction with HX forms gum dihalides. So alkynes, when alkynes on reaction with hydrogen halides such as HCl or HB or HI adds to alkynes to form gum dihalides, initially forms alkynyl halides, which on further reaction forms gum dihalides. So let me take one example here. CH when added to HBr. So here HX is either HCl or HBr or HI. Right here on reaction initially forms proton, one hydrogen attached to one carbon and bromine attached to the second carbon. Which on further reaction again, this second one happens according to the Markovnikov rule, H, and here. This is nothing but gum dihalides are formed. So this is the reaction with hydrogen halides, right? So the second one, first one, there is no problem. If it is also, then according to Markovnikov rule, we have to write. So here in second case, here the product is forming according to the Markovnikov rule. That's why we are getting gum dihalides. So this is the next one, reaction with hydrogen halides. Next one is reaction with water. So in alkenes also we have seen the reaction with water. So alcohols are formed, but here reaction with water is quite different reaction. Right? When alkynes on reaction with water in the presence of mercuric sulfate by sulfuric acid. In the presence of mercuric sulfate by sulfuric acid, initially enols are formed. Enols are formed which further undergo tautomerases to aldehydes and ketones. So alkynes water in the presence of mercuric sulfate and dilute sulfuric acid. So initial ga ever form avutunnaru cheptunam enols form avutunnaru. ఇవి ఫర్దర్ గా ఏమైపోతున్నాయని చెప్తున్నాం టాటోమరైజ్ అయ్యి ఎవరు ఫామ్ అవుతున్నారని చెప్తున్నారంటే ఆల్డిహైడ్స్ ఆన్ కీటోన్స్. ఆల్డిహైడ్స్ కానీ కీటోన్స్ కానీ ఫామ్ అవుతారు. సో మనకి ఇఫ్ యూ కంపేర్ ద రియాక్షన్ ఆఫ్ వాటర్ ఆల్కైన్స్ అండ్ ఆల్కీన్స్, సో మనకి కంప్లీట్ గా డిఫరెంట్ గా జరుగుతుంది. అంటే మనకు అక్కడ కంప్లీట్ గా యాడ్ అయిపోయి ఆల్కహాల్స్ ఫామ్ అయిన ఆల్కీన్స్ లో తీసుకుంటే కనుక, కానీ ఇక్కడ మనకి వి రిక్వైర్ సమ్ catalysts such as HgSO4 or H2SO4. Dilutes mercuric sulfate by H2SO4 presence లోనే ఇక్కడ రియాక్షన్ జరుగుతుంది. సో ఇక్కడ వాటర్ టు in the presence of HgSO4 by H2SO4. Right? One in here H plus and OH minus. Proton adds to the one carbon, OH minus attacks the second carbon. So here CH. Here double bond COH. So these are nothing but old En double bond containing compounds. OH group are called old. That's why this is nothing but En. And which further tautomerizes to aldehydes CH3CH. So this is the final product. When alkynes on reaction with water in the presence of mercuric sulfate by sulfuric acid initially forms enols which further tautomerizes to aldehydes and ketones. So this is the reaction with water. Then next one is polymerization. Cyclic polymerization. So when acetylene gas is passed through red hot copper tube or iron tube. Red hot copper tube or iron tube. Benzene is formed. Right? When acetylene gas is passed through red hot copper tube or iron tube, cyclic polymerization occurs and benzene is formed. So three red hot copper, we will get benzene. Right? So this is the cyclic polymerization reaction of ethane. Cyclic polymerization reaction of ethane. When acetylene gas is passed through red hot copper tube, here cyclic polymerization reaction occurs and benzene is formed. So these are the various physical chemical properties of alkynes. One is reaction with sodium, reaction with soramide, and then reaction with halogens, reaction with hydrogen halide, reaction with water, and cyclic polymerization. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.